fine understanding about the pile foundation, how to determine the bearing capacity of a individual. Okay, so today let us discuss about another kind of a deep foundation, that is pile foundation. So before you understand about the pile foundation, so there is a small classification system with regard to the foundation that you need to understand. Uh, when you say So a system has been proposed by several people. So initially it was the Terzaghi who proposed or who tried to distinguish between shallow and deep foundation. His proposition was, if df by b is approximately equals to 1, so then below 1 it is called as a shallow foundation, and above 1 it is called as a deep foundation. However, such classification system was later refined, and they said if df by b is less than 4, then it can be called as a shallow foundation, and if df by b is greater than 4, then that can be called as a deep foundation. And again, in shallow foundation, we have understood and seen a different variety of footings as well as the mat foundation. So that is called as a raft foundation. If the whole area, that is foundation area, is less than 0.5 of the whole area, then that is called as a footing. While if the foundation system occupies an area which is greater than 50% of the whole foundation area, then that is called as a mat foundation. So among the footings, we try to understand about isolated footing, combined footing, raft, strip footing, so on and so forth. So among mat foundation, there is only one variety, that is called as a raft foundation, or alternatively it is also called as a mat foundation. So in the case of a deep foundation, there are pile foundation, so there are Kaizen foundation, there are well foundation, and there are drill raft, so on and so forth. So among these, the pile foundation is widely used, so therefore we can discuss about only the pile foundation. So these are the distinction between different variety of a deep foundation. So above picture on your left side, you can see, so these are the piers, and below picture on your right side, so this is called as a well foundation. So well foundation is one of the kinds of a deep foundation. Similarly, pile foundation is one of the kinds of a deep foundation. Now how do you define the pile? Now in case of the shallow foundation, what we understood is uh, a footing is a structural member where it transfers the superstructure load safely from superstructure to the soil. So this is an intermediate structural element which safely transfers the superstructure load to the soil. However, in case of the deep foundation, what is the meaning of that deep? So what is happening? So here, with regard to the deep, so we can connotate two terminology. One is the foundation or the structural member itself is inserted very deep into the soil system. Second thing is the load transfer also from ground surface to the deeper level. So this is why it is called as a deep foundation. As you can see on the right side top picture. So these are all the pile groups, and where you can see the arrows, so which are pointed upward, indicating that when the load is getting transmitted from upward to the downward, the resistance is offered against the loading direction. That's why so the arrows are pointed upward. And alternatively, so here you can also see the arrows in the left and right direction, indicating that the load transmission happens all along from top of the pile, that is ground surface, to the bottom of the pile. So there are variety of pile systems exist in the system, which we will discuss and try to understand what are the different varieties of the pile foundation systems and how do you classify the piles also. But in a nutshell, if anybody will ask you how do you define the pile, so it is a slender structural member installed in the ground to transfer the same superstructure load to the soil. However, the load is transmitted from the ground surface to the deeper strata. So which was not in the case of the shallow foundation. It was only through the cross-sectional area of the footing, because there the length and width of footing is a definite width. Say 2 meter by 2 meter, or 2 meter by 3 meter, or 2 meter by 4 meters, on and so forth. The only base of the footing is going to get transmit the entire superstructure load to the soil. But here the entire structural element as shown here, so it transmits the load from top to the bottom. So how it exactly transmits and how to quantify how much load it gets transmitted, so that's what we will try to understand in this chapter. Now there is another thing that is called as a drilled shaft. So it is also somewhat relevant or attached with the pile foundation only. So in most of the cases, the pile and drilled shaft are so interlinked, or they are connected one element with the another element, or alternatively, often you may see the pile foundation alone or the drilled shaft alone. So these are the drilled shaft. Here also you can see this also looks like exactly like a pile foundation, but so here the bottom of the drilled shaft is relatively embedded in the hard stratum. Say for example a rock. So that's what is the major difference between pile foundation and the drill foundation. Drills are always attached with the hard stratum, while pile foundation may be attached to the hard stratum, may not be attached to the hard stratum. It simply might be hanging within the soil system only. So this is how the load transfer occurs between the shallow foundation and the deep foundation. So I don't need to re-emphasize again how the load transfer occurs in case of the shallow foundation. So as you can understand from this simple picture, so this is a shallow footing, and we can approximately assume the load transfer in the form of 2 vertical to 1 horizontal, that is approximately 45 degree, and these arrows indicates how much over wider distance the load gets transmitted beneath the soil strata. Now if anybody will ask you to draw what is the variation of the stress, so right beneath the footing there is an immense amount of the stress development, so that is called as incremental stress, or alternatively what do you call as so delta P. So there is another terminology that also we have seen, initial effective overburden pressure or initial effective stress, then increase in effective stress. Initial effective stress means it is the load because of the self weight of the soil, while increase in effective stress means this is the stress caused by the construction of the footing. So that's the difference. So here you can see the increase in effective stress is maximum right at the ground surface, and as you go deeper and deeper, so it becomes almost zero. And same kind of analogy is valid in case of the pile foundation also. However, here the load transfer occurs from both the sides in two ways, meaning thereby the load may get transmitted from the bottom of the pile foundation as shown here, as you can see delta P diagram. So it is highest right at the tip of the pile, bottom tip of the pile, and thereby so the delta P keeps on decreases with further increase in depth of the soil strata. At the same time, the surface area also might be contributing for transfer of the stresses. So that's what is another distinction in case of the pile foundation. So when you talk about the shallow foundation, the load transmission occurs only through the bottom of the footing, only through bottom surface area of the footing. While in case of the pile foundation, so there are two means by which the load gets transmitted, that is through bottom tip as well as through the surface area over the entire depth from top surface to the bottom tip. So these are the two mechanisms by which load gets transferred in case of the pile foundation. Now another important thing as a civil engineer that you must understand is under what circumstance the pile foundation must be adapted. So there are several circumstances. The first, the very simple one is since we elaborately understood about the shallow foundation, now the shallow foundations are may not mean for every kind of the structural loading. So wherever the shallow foundations doesn't meet the criterion in terms of the settlement or in terms of the bearing capacity, then the next best solution is go for the pile foundation. Now there are other limitations also. For example, the foundation, the soil bearing capacity requirement is very high. The second condition is, suppose if the load coming is purely lateral. It's not an axial load. Under those circumstances, one has to go for the pile foundation. Then in other cases where the foundation should be right in the water, where there is a possibility of the development of the uplift pressure means the pressure from the bottom of the foundation system. So usually, so in shallow foundation, we understood that the load only gets transmitted from or through the foundation into the soil. But what if there is some amount of the load exerts against the direction of the load which gets transmitted? So that is called as uplift pressure. So usually the presence of the water or the water in the dynamic condition can exert a lot of the uplift pressure. So wherever there is a problem of uplift pressure, there we can go for the pile foundation. Or alternatively, we can also go for if the soil is a problematic. For example, there are soils like a swelling soils, there are soils like a collapsible soils, or the soils which are highly compressible. So in all these conditions, wherever you found that there is some problem with the soil, then in all those circumstances, instead of going for the shallow foundation, we can think of to go for the deep foundation. And in case of the bridge piers, or where there is a probability of the foundation system going to be subjected to the immense amount of the scour, especially at the riverbeds. If you look at the foundation system within the riverbed, maybe of the bridges or towers, so all of these systems will basically comprise of deep foundation systems. So these are different variety of piles which are available, or which are classified based on the load bearing capacity or the load governing criteria. Now a pile may be purely designed to carry axial load as shown here, uh, and here when I say axial load, so the axial load of the axial load resistance could be in two forms. One is called as a point bearing, next is called as a friction. I will explain in detail about these two in the subsequent slides. Then wherever there is an inclined load or horizontal load, so depending upon the inclination of the load, may be inclined or may be horizontal, then a pile called as a tension or anchor pile. The first one is point bearing pile, friction pile, tension or anchor pile, laterally loaded pile, compaction pile, seat pile, and pile to safeguard foundation against. So these in all these circumstances are pile foundation is necessary, or depending upon the kind of the load the pile foundation is going to subject it, then it can be classified as any one of these piles. Now for your undergraduation problem, in fact pile foundation itself is a full one semester course. In fact it is more than that. Say 1 year can be covered only on the pile foundation system. So this is such an exhaustive and vast syllabus. However, for your case, we are going to cover only the pile which is going to subjected to the axial load. That is A and B. These are the two cases which are going to be covered for your UG syllabus. Okay, so rest all are dependent. So even for post graduation program also, it is difficult to cover even every kind of these file systems. So there is another classification of the file system depending upon the material that you use, or alternatively depending upon the diameter of the file, or depending upon the inclination of the load. As you can see here, based on the cross-sectional area, a pile can be a circular pile or a square pile or H pile or octagonal pile or tubular pile. Any type of the pile you can adapt in the system. And based on the size, so if the diameter is less than 150 millimeter, it is called as a micro pile. If the diameter is exceeds 150 millimeter, then it is called as a small diameter pile. But in reality, you can also see the pile diameters as large as up to 1.5 meter. And if the diameter exceeds 600 millimeter, then it is called as a large diameter pile. And based on the inclination of the load, so a pile may purely be carrying the axial load or inclined or the lateral loads. Now, depending upon the material used, they are called as a steel pile, concrete pile, composite pile, timber pile. Very earlier, people used to use extensively the timber pile, but nowadays the use of concrete piles are prevalent, and even steel piles also. We use the steel pile, but in different circumstance. But that is not called as a pile; it is called as a seat pile. So most of the steel piles are used to construct seat piles, and depending upon the load transfer, so if entire load gets transmitted only through bottom tip of the pile, that is called as a end bearing pile, or alternatively if the load transfer occurs through the surface area, then that is called as a friction pile. Then a method of construction, as a civil engineer you must understand about the four different variety of the piles, that also I will demonstrate: driven piles, bored piles, cast in situ piles, screw piles, jacket piles, so on and so forth. Then depending upon the purpose or the use, they are called as a load bearing, compaction, tension, seat, anchor, so on and so forth. Based on the displacement, they are called as a displacement pile or non-displacement pile. So here, this slide will give you a deeper understanding about two fundamental phenomena that you must understand very carefully and you must remember for your entire life, as long as you are dealing with the pile foundation. So whenever you deal with the pile foundation, we always ask about two important questions. One is, uh, are you designing the file as end bearing file? The second one is, are you designing the file as a friction file? Now, how do you understand that distinction between the end bearing file and the friction file? So I will try to explain as elaborately as possible. If you have any questions, please feel free to ask, because if you do not understand this critical point, then in all subsequent classes you might not be understanding about what's arrest hold and what is the meaning of end bearing file or what is the meaning of the friction file. So let us look at first end bearing file. So from the term itself, end bearing pile. So there is a pile. The entire load transmission happens only at the end of the pile. Only at the end of the pile. Now as you can see here, so if you look at the tip of the pile is directly resting on the hard stratum. Directly resting on the hard stratum. So when such occurrence happens in the real life, so it is said that the majority of the load transmits only through the end, pile end. These are called as a end bearing pile, end bearing pile. Now alternatively, now suppose say where the pile is simply hanging in the soil. Now here you can see, if you see your left side diagram, you can establish a connection between superstructure to the hard stratum. There is a direct connection, and thereby we can presume that the load gets transmitted only through the tip of the pile, and at the tip of the pile, the hard stratum such as a rock exists. So rock is a hard stratum; it can directly able to take any amount of the load which gets transmitted from the pile. So as such, there is no problem. But alternatively, or contrary to this one, let us assume where the pile is hanging within the soft soil. The pile is hanging within the soft soil, where the tip of the pile is not resting on the hard stratum. Tip of the pile is not resting on hard stratum. Now, as the tip is not resting on the hard stratum, we can no more presume that there is a transfer of load through the bottom. So there is transfer of the load through the bottom. Such case will not happen. Whatever the load that is coming from the superstructure will simply has to get transmitted to the soil within which the pile foundation is hanging. That is basically through the surface area. So here it is shown, these arrows pointing upward will indicate that the load transmission is happening only through the surface area in the form of a friction. Now how how and where this friction get develops. So this friction get developed between two contrasting materials, that is soil and the concrete. So as you know from your different subject, so here pile is a concrete material while the soil is a pulverized material. So obviously unless otherwise a friction that gets developed while transferring the load from the pile to the soil, no amount of the load gets transmitted to the soil. So this friction is called as a, so is normally designated as a frictional pile. Okay, so anybody has any question?
Sir,
Yeah.
sir, in friction piles, the soil is loose soil or which type of soil?
It may not be a loose soil. It can be of any kind of a soil, doesn't matter. But the fundamental thing is that the tip of the pile is not resting on the hard state.
Sir, if it is very loose soil, friction is developed and how it can bear the load?
Uh, in almost every kind of a soil, if you try to insert, it try to resist some offer. So that is in the form of adhesion. Suppose if the same friction develops between the two similar kind of a material, that we call as a cohesion. But here in the form of adhesion. So that adhesion is the responsible for transmission of the load. Now suppose say, as you were asking, since if the soil is very soft, could it able to take the load? Just try to imagine. We are not transferring the load only at one point. We are transferring the load over the entire length, and this length is a one of the deciding parameter. So as the soil becomes loose and loose or soft and soft, the length of the pile requirement is higher and higher. Okay, for example, if the soil is stiff clay, maybe you require only 10-meter length of the pile, because the stiff soil reasonably develops the adhesion between the pile and the soil. As the stiff soil converts into from stiff to the soft, the value of the adhesion decreases. Then, so the length of the pile increases. So ultimately, you have to meet the criterion of the load, superstructure load. So as the soil is further becoming the soft, then you may be requiring more and more length of the pile. Is it clear?
Yes, sir.
Okay. So others?
Yes, sir.
Yeah, please ask. Any question? Okay. So these are called as a, this is a simple schematic that is showing how the pile look like. So these are pile which has been cast on the ground. So you can see the length of the pile, you can imagine, and these are the piles which have been driven into the ground. So these are also different piles. This is a structure built on the pile foundation. So all these are piles. There is something called as a displacement pile and non-displacement pile. Displacement means if you drive anything into the intact ground, it tries to displace the soil. While alternatively, you can avoid the displacement by making a small borehole with the help of the auger, with the help of the drill bit. So if you make a borehole, that is called as a non-displacement of the soil. And if you do not make the borehole and directly drive the pile, that is called as a displacement pile. There are four fundamental terminology that everyone as a civil engineer must understand about the pile foundation. So those things are, the very first is driven precast pile. So here you can see on your left side picture. So this talks about the driven precast pile. So here the pile is cast in the ad and brought to the site and is driven into the soil mass. So there are, from the word itself you try to understand, just to avoid the confusion. Driven precast pile. So we have constructed the pile on the ground, that is called as a precast on the ground, and this cast pile is driven into the ground, that is called as a driven precast pile, or alternatively driven cast in situ pile. Here first a casing plugged at the bottom, as you can see here. So on your right side picture, a casing plugged at the bottom is driven into the ground, and then the pile is casted by removing or retaining the casing. So instead of the pile, in the earlier case, the pile is directly cast on the ground, brought to the site and driven with the help of some equipment. So maybe a crane, or maybe there is specific equipment available for the pile driving. Now suppose if I initially drive the casing instead of the pile, then that is called as a driven cast in situ pile. Now alternative to driving, because in every circumstance we can't able to drive the pile. So the driving is possible if the soil is soft. Try to understand, the driving is possible only when the soil is soft. But if the soil is not soft, say for example if the soil comprises of some kind of the pebbles or gravels or hard strata, or like for example let us look at our campus. So you cannot say that our campus comprises the soil of the soft. So here we can't able to drive the pile. Then what is the next best alternative? So in that case we have to make a bore. So that is called as either driving or boring. So these are the two things. The second thing is you cast the pile on the ground, either directly drive, or you can directly cast the pile within the bore. So these are the things. So bored precast pile means a bore is made first, then the soil inside is removed, then the pile casted in the some ad is put into the bore. Okay, so in case of the driven precast pile, the pile which is cast at the ad is directly driven without making the borehole. In the case of the bored precast pile, we initially make a borehole, and the pile which is cast in the ad is brought to the site and directly inserted into the borehole. That is called as a bored precast pile. And another variety is bored cast in situ pile. So here you first make a borehole, a bore is made, the soil is removed, and the pile is casted at the site. So here there is no casing. In case of the bored cast in situ pile, no casing. The borehole is made and the pile is cast from the bottom to the top. So these are the four important terminology everyone must remember. So if you have any question, please ask me now. So these three slides are the core to understand the pile foundation, because all IS codes, all textbooks, they talk about pile foundation, but is the pile foundation is meant for end bearing or the friction? That is most important. Then what kind of the pile it is a driven pile or bored pile? So this is where everybody will ask you the question.
Sir,
Yes.
sir, the base of pile foundation is large. So, sir, how can we put, means how the precast pile can be made, sir?
How precast pile? Now we will make directly on the ad. Na? Ad
No,
means
sir, in left image, sir, the base hole has larger diameter.
no, it doesn't matter. See, in case of the driven pile, say for example here in case of the driven pile, the end may be like a point, a tip. It may not be a blunt surface. You can make it as a tip. But as I told you, if you want to drive the pile, the soil has to be relatively soft. Then only we can drive. Otherwise, during the driving in hard soil, the pile may break.
Okay.
Okay, so it's not possible to insert. The driving is not valid for all circumstances. No, there are a lot of instances where pile got broke during the driving. So this is also one of the reason. Unless otherwise the soil is immensely soft, they will not venture into going for the driven piles. A simple example I can tell you is, suppose if you go to Paradip site, or Paradip town. It is a very, very soft soil. There it is possible to drive. But if you look at our campus, it is a lateritic soil. If you drive anything, you are simply breaking that pile. That's it. Okay, if you don't have any questions, then I can proceed further. Okay. See, yeah, when you talk about the pile foundation, you have to understand about what are the different loads that pile could able to carry. Then in how many modes the pile foundation could fail. Since the pile is inserted deep into the ground, now there are two things that can happen. The pile may first fail, followed by the soil, and vice versa. The soil may fail, but the pile may be intact. So therefore, so you need to understand which one is failing first. Is the soil failing first, or is the pile foundation failing first? And in most of the time, you see, in case of the shallow foundation, we understood that the failure criterion is general shear failure or the local shear failure. But in case of the pile foundation or any deep foundation, it is the punching shear which is responsible for the failure of the pile foundation. And regarding the loads, you can talk about all dead loads, live load, wind load, seismic load, and load coming from the wave load, earthquake load, so on and so forth. All kinds of the loads can be considered. And depending upon the kind of the load that is coming, that you can design the pile as axial pile or the lateral pile or raker pile. That is, the piles are inserted in the inclined direction or seat pile, so on and so forth. So there are a variety of means are available to drive the pile. So these are called as the pile installation. You can go for a drop hammer or single acting hammer or double acting hammer or diesel hammer or vibratory hammer. So these are the different hammers which are available for driving the pile. Again, I repeat, so these equipments are meant to drive the pile only. So not meant for making the borehole. Now, why do you need to go for different variety of the equipment? Because the soil types are varying. For example, if you look at the vibrator hammer is exclusively useful for cohesionless material such as a sand. Unless you apply the vibratory mechanism, you cannot make displace of any kind of a material, or you cannot insert any material into the cohesionless material. Or suppose if you are dealing with the soft soils, then you can use the drop hammer. So or single acting hammer or double acting hammer or diesel hammer. So these are the different pile driving equipment. So this is called as a drop hammer. So here a heavy weight, that is called as a rammer. So rammer is lifted and dropped repeatedly. Here you can see the picture of the dropper. So rammer. Repeatedly this rammer is lifted and dropped. However, so since the weight of this rammer is so heavy, you need to provide some kind of the cushioning mechanism on top of the pile, which otherwise you may be breaking the pile top. You may be breaking the pile top. So therefore, as an engineer, you must exercise enough precautions not to cause any kind of damage to the top of the pile. So when you drive it. So these are the diesel hammers. Here you can see how it is holding the pile, large piles, and how it is driving. So this is hydraulic drop hammer, underwater pile driving. So these are the beautiful pictures. So then vibratory hammer. So the fundamental mechanism is it vibrate the soil material and thereby facilitate driving of the pile into the soil mass. So there is another kind of a pile that is called as a seat pile. So in case of all previous discussions, for example, if you look at here an isolated element is driven into the ground. So a simple slender structural element is driven into the ground. But alternatively, suppose if I take a H section pile and a series of H section piles are driven one right adjacent to the another, such that the series makes some kind of the barrier. That barrier is called as a seat pile wall. So here so many number of piles are installed one adjacent to the another. So that forms some kind of the wall. And since you are using a single one sheet of the pile material, that is called as a sheet pile wall, or alternatively, when this series is constructed, this makes or this looks like some kind of the sheet. That's why it is called as a sheet pile wall. See, this entire thing you can see. So all these are interconnected. In case of the pile foundation, they are not interconnected. But in case of the sheet pile, they are highly interconnected. So they are interconnected so tightly that so they act as water barrier also. They will not allow movement of water from one side to the another side. And the way of analysis or the mechanism that governing the sheet pile wall and the pile foundation is different. So in case of the sheet pile wall, the design mechanism is based on the theory of earth pressure, while in case of the pile foundation, so it is based on the end bearing pile or the friction pile. So these are the different piles you can see. So these are the pile and these are the drillet shaft. And suppose if you uh, install the piles one adjacent to the another such that it is making a sheet. So that's why it is called a sheet pile. So this slide try to give a details about our fundamental distinction between three variety of the pile foundation. So the above is pile foundation. So there is a superstructure and there is a pile cap and there are piles. So these are the piles which are integrated with another structural element that is called as a pile cap, and on top of the pile cap a superstructure is built. Now alternatively, drillet shaft means the bottom of the pile, if it is inserted into the hard stratum.
Sir,
Yeah,
sir, sir, pile cap is like a mat.
it is like a mat, correct.
Oh, okay, sir.
Yeah, it is a mat. And suppose say if the bottom of the pile is little enlarged or inserted by some other mechanism into the rock, then that particular pile is called as a drillet shaft. So that's why, as I told you, so often drillet shafts are integral part of the pile foundation, but reverse is not possible. A pile can be independent, but drillet shaft is always an integral part of the pile foundation. And there is another pile foundation that is called as a sheet pile. So we will discuss about only the pile foundation among these three for your undergraduation. So these
Sir,
are the
what is the difference between drilled shaft and pile foundation, sir?
see, suppose if you directly insert the pile into the soil without having any kind of other governing mechanism at the bottom of the pile, that is called a simple pile foundation. Alternatively, for example, there is a rock stratum at the bottom, at the pile bottom. Then in that rock, either you enlarged the bottom of the pile foundation or you made some kind of special arrangement that is called as a socket, and into that socket a pile is installed. Then in that case it is called as a drillet shaft. Okay. And in case of the drillet shafts, so there is no driving is possible. As you can see, drilled shafts. So first you have to make a borehole by the drilling mechanism. Then you insert or cast the pile into the or within the borehole. You try to observe the bottom of the pile foundation in case of the drillet shaft and in case of the pile foundation.
Sir, in case of pile foundation also, sir, the bottom is little has more area, na?
No. In case of the pile, it is not
No, sir,
there.
but in last slide we have in board.
No. In case of the board, this is what you were talking about.
Yes, sir.
No,
Sir, here
here
na sir grouting at enlarged base, like base is enlarged.
grouting at enlarged base. Oh, enlarged base means when you do the grouting is always done with some amount of the pressure. For that pressure, it tries to push the soil into little in the lateral direction. That's why it is called as enlarged. But otherwise, there is no enlargement in case of the bored cast in situ or bored precast pile. No enlargement is allowed.
Sir, also in
But
this second
can
diagram also, sir, we
no,
can see that.
yeah. And in this case, the enlargement means the enlargement is there from the bottom to the top. It is not only confined at the bottom.
Oh, okay.
Okay. And in case of the drilled shaft, the enlargement is specifically designed. As you can see here, the bell shape. Bell shape. This is specifically designed and made available within the rock. Within the rock. Okay.
Okay, sir.
So these are the different installation steps involved in the boring. First you drill and insert the casing, then clean the borehole, then insert the reinforcement, then place the trimmy pipe to pour the concrete. So these are the different steps involved in bored cast in situ pipe. One way you can understand that this is a bored cast in situ pipe. Or alternatively, you can also go for augering. So you try to make a borehole by the augering, or you can use the drilling mechanism, or you can directly drive the pile into the material. So any of these three mechanisms you can use for construction of the pile foundation. So these are the, you can see how big is the auger. So these are all and they are scooping out the soil with the help of the augers. So this diameter of this auger is more than 1 meter. Okay, so I will stop it here. So maybe on Wednesday we can continue. So if you have any questions, you are most welcome to ask.